Welcome back to Infinity Beyond. In our last segment, we traveled to the coldest natural places in the cosmos, from the haunting Boomerang Nebula to the icy vistas of Pluto and Triton. Tonight, our journey continues, deeper into the frozen frontiers of our solar system, where ice isn't just frozen water, it's geology, chemistry, and mystery. Let's begin with one of the most captivating moons in our celestial neighborhood, Europa, one of Jupiter's many moons, and perhaps its most enigmatic. On the surface, Europa is a world locked in a deep freeze. Temperatures average around 160 degrees. But underneath its cracked, crisscrossed ice shell lies something astonishing. A subsurface ocean that might contain more water than all of Earth's oceans combined. And where there is water, the possibility of life follows close behind. Europa's icy surface is relatively young, geologically speaking, perhaps only 40 to 90 million years old, suggesting constant reshaping and melting from below. NASA's upcoming Europa Clipper mission, launching in the 2020s, aims to explore this frigid world up close. It will search for chemical signatures, study the ice, and peer beneath the surface using radar to detect the hidden ocean. Imagine what it might mean to find microbial life, or even just organic precursors, in the cold, dark ocean beneath Europa's surface. It would redefine our understanding of habitability and remind us that life doesn't need warmth to thrive. Sometimes life hides in the cold. Next, we drift to Enceladus, one of Saturn's moons. At only 500 kilometers in diameter, Enceladus might seem small and insignificant, but don't be fooled. It is one of the most geologically active bodies in the solar system. Through fissures near its south pole, known as tiger stripes, Enceladus spews plumes of salty water and organic molecules into space. These icy geysers form a massive halo of particles that feeds Saturn's E-ring. Scientists believe the geysers originate from a global subsurface ocean, kept warm by tidal forces from Saturn's gravity. Think about that, a tiny icy moon, shooting water into space, hiding an ocean beneath its frozen crust. Like Europa, Enceladus challenges our assumptions about where life could exist. And just as importantly, it highlights how much we still don't know about the cold, outer regions of our solar system. But the frozen mysteries don't end there. Have you heard of Ganymede? It's the largest moon in the solar system, bigger than the planet Mercury, and another icy giant orbiting Jupiter. Ganymede has an iron core, a magnetic field, and evidence of a multi-layered ocean beneath its icy crust. This ocean could be sandwiched between different layers of ice, creating a complex and dynamic environment. Ganymede's surface is a mosaic of ancient impact craters, grooved terrain, and light and dark regions, shaped over billions of years. Like its siblings, it whispers secrets of past geological upheavals and internal heat that defy its cold exterior. Then there's Callisto, another moon of Jupiter. It's one of the most heavily cratered objects in the solar system, suggesting an ancient, inactive surface. But beneath that frozen, pockmarked shell may lie a subsurface ocean. Unlike Europa or Ganymede, Callisto shows little sign of internal activity. But that very quietness makes it a potential candidate for human exploration. Its low radiation environment and icy resources could one day support bases or fuel stations for deeper space missions. As we float among these frozen moons, it's clear they're not dead worlds. They're icy laboratories, humming with geological processes and potential biological intrigue. They push the boundaries of what we consider habitable. And more importantly, they expand our imaginations. Let's zoom out for a moment and think about this. Our solar system is full of water, not just on Earth, but locked in moons, buried beneath crusts, floating in comet tails, and hiding in the shadows of craters. In the cosmic cold, water persists. And where water persists, so too might life. In ancient mythology, the outer solar system was associated with gods of mystery and the unknown: Uranus, Neptune, Pluto. It's poetic, isn't it? These icy domains remain among the most mysterious parts of our solar system, and yet they might hold the keys to answering humanity's oldest questions. Where did we come from? Are we alone? Let's not forget Titan, Saturn's largest moon. Titan is wrapped in a thick orange haze, composed mostly of nitrogen and methane. Temperatures hover at 179 degrees. Lakes and rivers of liquid methane and ethane flow across its surface, creating an alien hydrological cycle. Beneath that frigid landscape may lie another subsurface ocean. But even at the surface, Titan is extraordinary. It is the only moon with a dense atmosphere and stable liquids on its surface. It is so Earth-like, yet utterly alien. The Dragonfly mission, set to launch in the 2030s, will send a drone to explore Titan's dunes, lakes, and prebiotic chemistry. Titan may be cold, but it burns with scientific potential. All of these worlds, Europa, Enceladus, Ganymede, Callisto, Titan, remind us that the universe is vast, complex, and surprising. Cold does not mean sterile. Ice does not mean empty. In fact, the frozen moons of our solar system may hold more answers than the sun-drenched worlds we once thought were the only places for life. As we conclude this segment, take a moment to marvel at how much the cold can teach us, how ice can preserve, protect, and even harbor the ingredients of life. In our next journey, we'll venture beyond the solar system into the exoplanetary realms, where rogue planets, ice giants, and frozen super-Earths drift through interstellar space. Get ready to leave home behind and embrace the unknown, because out there in the cold, the universe is waiting.